Now here we're going to look at an example of a discrete probability model. Remember, the word discrete goes with outcomes that can be listed individually, like tossing a coin, heads, comma, tails. They can be listed individually, so that would be discrete outcomes. So a discrete probability model is where the outcomes can be listed individually and their probabilities are also listed, so that would be called a discrete probability model. So let's just look at the question number 6. This is important because many of your problems on the homework assignment are very similar to this particular problem. Now first read the question. The population here is young people, ages 19 through 25, and what we are measuring is, in the past 7 days, the number of days that each individual watched television. So the response is a measurement. It's the number of days. It can be listed. So it's a discrete sample space. So the sample space here is 0, 1, 2, dot up to 7, because there are only 7 days in the week. So if someone says in the past 7 days, how many days did you watch television, there is a limit to it, so you can stop at 7. Now the first question says, is this a legitimate discrete probability model? It is discrete because the outcomes are listed. Individual outcomes can be listed. So if all outcomes are listed, so we're checking off the 4 conditions. Are all probabilities listed? That is correct. All probabilities are listed in the second row. And are the probabilities between 0 and 1? So they all look okay. They look like they've been calculated correctly. And do all the probabilities add up to 1? Since all 4 conditions are satisfied, it is a legitimate probability model. Now the next question is, it says, describe the event x less than 3 in words. So events can be described in words, or they can be a list of outcomes. So you have to know how to be able to do both, because for calculations we'll need to know what the list is, and to explain it we'll need to know how to use words to explain that outcome. So what does x less than 3 really mean? X is a variable, so here it's a count, so it's numerical, so you can call it x. Less than 3 would mean x is 0, 1, or 2. So what exactly does that mean in the context of this problem? It means that it is the event that a young person in the age group of 19 to 25 years watched television less than 3 days in the last week. Now if you see the letter P, uppercase P, in front of an event, then that means you need to figure out the probability of that particular event. So we're trying to find the probability that x is greater than 5 or x is less than 3. So the two events, x greater than 5 and x less than 3, are clearly disjoint because the two cannot happen together. If a number is greater than 5, then it definitely cannot be less than 3 as well. So all we have to do is add the probabilities of the two individual events to get the probability of x greater than 5 or x less than 3. So what is the probability of x greater than 5? It would have to be 6 or 7, so we add the individual probabilities. And next, for a probability of x to be less than 3 would mean it can be 0, 1, or 2, which means we add the probabilities of 0, 1, and 2 to get the probability of x less than 3. So 6 plus 4 is 10, plus 3, 13. that would be the total probability for x less than 3, and 0.05 plus 0.57 is 0.62, and that would be the probability that x is greater than 5. So the probability that x is greater than 5 or less than 3 would be adding these two probabilities, and that would give us a 0.75. Now it says express the event watched TV at least once in terms of x, which means can you list all possible outcomes that would represent the event watched TV at least once. At least once means once, once or more. So you watched it one time or more than one time. So there would be 1, 2, 3, 4, 5, 6, 7. These are the individual outcomes that make up the event at least once. At least once means one or more times. So that would be 1 through 7. Probability that someone watched television at least once would be 1 or more times. So basically you're adding up all these probabilities. Let me use a darker shade here. 1 or more times, adding all those probabilities, starting with the 0.03, the 0.06, 0.08, 0.09, again 0.08, 0.05, 0.057. Everything together gives you a 0.96. The only outcome that we excluded was the first one, that is did not watch TV at all. So another way of looking at the same problem is watching TV at least once in the 7 days would be all events excluding just one, which is did not watch TV at all. At least once, the opposite of at least once is not at all. So watching TV at least once, the opposite of that event would be did not watch TV at all. So if we use one of the rules that we discussed earlier, which is the rule of complements, we can use the formula probability that someone watched TV at least once is 1 minus probability of the opposite event. So that is equal to 1 minus probability that the person did not watch TV at all. So that would be 1 minus the probability of not watching TV at all according to the table is 0.04. So that would be 0.96. So we get the same answer in two different ways. So here we've used a formula which makes it just easier to calculate the probability. So at least the opposite of that is none. So at least once did not watch at all, so that would be none, and that's how we figure out the opposite event. What is the probability that x equals 5? That is, what is the probability that a young person watched television exactly 5 days in the last 1 week? So that would just be right out of the table. Probability of x equals 5 from the table is 0.08. What is the probability that x does not equal 5? So does not equal 5 is the opposite of equals 5. So probability that x does not equal 5 is 1 minus the probability of the opposite event. So that would be 1 minus probability that x does equal 5, and that would be 1 minus 0.08. That is the probability that x equals 5, and that is 0.92. So that's just another example of where we can use the rule of complements. That's what it's called. Probability of a certain event is 1 minus the probability of the exact opposite event, or the negation of that event.